Okay, good morning, everyone. This is Oliver Hua on behalf of Math Club for question number 4 and 5 of the co-op stage for math challenges. And these are some interesting questions, for sure. For question number 4, I'll give you some time to pause the video and read the question, as well as question number 5, before I go over them. Okay, so the biggest mistake that I feel like will happen for you guys, I'm not too sure, is mistaking the value for the heads and the tails. So one of the biggest mistakes probably would be if you wrote, or would be one of the biggest mistakes is if you wrote 1/4 as the odds for tails and 3/4 for the odds for heads. And the reason why this is wrong is because if you express this as a decimal form, I think this is a better way to visualize it. This would be 25 and this would be 75%. And so the increase of this one to this one would actually be a 300% more chance. This would be 300% more likely. Rather than this case, which would be the correct case, and it would be 40% to 60%, which I'm hoping you guys can see is a 50% increase, or more chance of getting heads than tails. Right, so now on to the solving part of this question. And so there's 3 cases which is one of the ways you can approach this question. One of the cases would be if you started off with tails, heads, right? And then this last one, it doesn't matter if you get a tails or heads. And then another case would be if you got a heads immediately, a tails. And I'm going to save this spot for later for one of the other cases, so this will be my blank spot. So it doesn't matter, again, if this is a tails or a heads, because either way I still have that 3, which are the same. And my final case will be if those 3 tails are in the middle and surrounded by 2 heads. And so now it's just a matter of calculating the odds for each case. So for the first case, you'll have the first tails is a 2/5 times 2/5, right? Times 2/5 times another 2/5 times the odds for heads, which is 3/5, and then multiplied by 1, because this can be either 1, it doesn't matter, so we'll just write 1. And this case is pretty much the exact same in terms of odds, so we'll just multiply this one by 2, which will suffice for this case as well. And for the final case, it is 2/5 for the 3 of those, so 2 to the power 3, times the odds for the 2 heads, which is 3/5 squared. And so now all we have to do is add these 2 up, and then we'll get the answer for this question. And so when you're adding this up, we can see that we have, what is that, I have one too many of these, don't I? Okay, so I have 1, 2, 3, right? 3 for this, 3 heads on the top, and then a 3/5 here. And so that's 2/3 times 3 over how many 5s do I have? 1, 2, 3, 4, 5 to the power 4 on the bottom, and all of this multiplied by 2, which I could just put to 2 to the power 4, but that's fine. And then for the second case, we can see that is 2 to the power of 3 times 3 squared over, looks like there's 5 5s on the bottom. Right. So we're going to add these 2 cases up. Bless you. And so we can see that that's 8 times 3 times 2, 48. Again, you're allowed a calculator for this part of the test. And then the bottom will be 5 times 5 times 5 times 5, 625. And then that is added to this part, which is equal to 8 times 9, 72 over 5 to the power of 5, which is 625 times 5, which is 3125. Of course, we're going to multiply the top and the bottom by the same number, and that'll give us 48 times 5, 240, plus 72 over the same denominator, 3125, and that will give us 312 over 3125. which should be your answer for question number 4. Okay, moving on to question number 5. For this question, we'll use pattern recognition. So we'll see what a couple smaller polygons will have, how many diagonals they have, and then we'll move on to larger polygons afterwards. And so the smallest polygon that you can create is a 3-sided one, right? A triangle. Because if you had a 2-sided polygon, it would just be a line. And so with the 3-sided polygon, you will have no diagonals. And you can see that because if we do draw a line from any given point to one of the edges, it'll just be the exact same one. It'll just be exactly the same as one of the side lengths. And that is not what is classified as a diagonal. So moving on to a square. Let's write 0 here. You can see that there are 2 diagonals. One from these 2, so we'll have two diagonals, right? Creates an X, very fun. For a pentagon, you can see that we'll have 1 here, 1 here, 1 here. Oh, oops, my bad. This one is not 1 because, again, it's going from one of the 2 side parts. So we'll have 2 from this point. We'll have another 2 from here and here. So these 2 right here, these 2 right here, and then finally 1 more from here to here, which coincidentally looks like a star. So that'll give me 5 total. Of course, 1, 2, 3, 4, 5. And then the larger we go with the polygons, or the ones with more sides, the harder it is to draw. So I'll try my best here, but I have 1 here, 1 here, 1 here. And that gives us 3, right? And of course we can't attach to any of these 2 because those would just be the side lengths. So we'll go to a different point. So there's 1 here. So that brings up the count to 4. There's another one. That's 5. That's 6, right? On this point we have 1 here, but we already did it. So we'll only go to this one. So that's 7. And that's 8, right? This one, it looks like there's only 1 more to go for, which is this one right here to here. And that would be our 9th one, because once you go here, you can realize that we already counted all the ones that it could have. So in total, this one has 9. And so now let's look at the numbers and look at the patterns that we can try to create from these things. And I wouldn't use 0 first off, because I feel like it's kind of not right, but you can clearly see that this is an increase of 3, and this is an increase of 4. And so off intuition, oh, and if you go from 0 and you increase by 2, so I guess you could use 0 there, whatever. You can see that this is 5, and then if you add 4, you'll get to 9. And so this is a 3-sided polygon, this is a 4-sided, 5-sided, 6-sided. So then the 7th-sided polygon will have this plus 5, just based on our table that we have. So that gives us 14. Our 8th one will have plus 6, which will give us 20. So we'll have 20 on the 8th one, and then plus 7 we'll get to our 9th one, which will have 27 diagonals, which is the number we're looking for. And so the answer to this question of what sided polygon will give us 27 diagonals, your answer will be 9-sided, where n is equal to 9. Okay, that pretty much wraps up all the questions I have to go over. Have a great winter break. I'll see you guys next year. Thank you.